Last week we spoke about the fight-flight response in some detail. We spoke about the sympathetic and parasympathetic nervous systems, we spoke about the HPA axis, and we spoke about the hypothalamus, which serves as a central coordinating point for both of those systems. It serves to engage the sympathetic nervous system response for fast, immediate response to threats and challenges in the environment. And in parallel, it activates the slower hormonal HPA axis response, which serves to help to maintain that sympathetic nervous system response. And then we also spoke about two specific hormones that are released from the HPA axis, from the adrenal glands of the HPA axis. Adrenaline, which serves primarily to amp us up, and cortisol, which serves to suppress inflammatory responses in the body. So today we're going to build off of that, and we're going to talk a little bit about what the acute effects of the system on the body are. So we're going to focus a little less on the underlying mechanisms, that was last week, and we're going to focus a little bit more on what the effects of that system response on different parts of the body are. Now, like last week, it's going to get a little biological at times, but I'll try to go slow enough so that even people without biological backgrounds are able to keep up. Okay, so let's go back to our favorite example. Tiger jumps out at us. This is probably the last time that I use that example for a while. I'll start using more relevant stressors going forward. But since we're still right now talking about immediate, acute, active, evolutionarily adaptive stress responses, it still makes sense to talk about this tiger. So, tiger jumps out at us. Our amygdala fires, threat, 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 sends information to the hypothalamus, which activates the sympathetic and the HPA axis systems. Adrenaline and cortisol are released, and what? Well, first, the sympathetic nervous system sends messages through efferent neurons to the striatal muscles of the body, and that causes you to tense. Now, that tensing is what allows you to either freeze or to flee and get the hell away from the stressor. The thing is, whether you freeze or you flee, your muscles require energy. And so a number of other systems also ramp up to ensure a sufficient flow of energy to the muscles and to other essential components of the system. In particular, adrenaline release leads to an increase in heart rate and an increase in stroke volume, which is the amount of blood actually released on each contraction of the heart. And at the same time, your blood vessels constrict. And so your blood ends up coursing through your body faster and stronger to ensure faster circulation of nutrients through the system. This is why your pulse may feel stronger when you're stressed, or why you can actually feel your heart in your chest sometimes, or even sometimes in your ears, because the blood is actually flowing through faster and stronger. At the same time, a number of nutrients are released into the bloodstream so that they can circulate through your body as needed. Glucose, in particular, is the body's primary energy source, and it's released into the bloodstream at a faster rate. At the same time, your lungs, the bronchi of your lungs, dilate, which allows more oxygen in and out of the body. And this allows the oxygen to also circulate through the bloodstream faster. That's also why you end up out of breath and short of breath when you're stressed at times. Not because your chest constricts, although that can happen as well, but because your bronchi actually open up and allow more oxygen in and out of the body. Finally, your sweat glands activate more and start producing more sweat, so that the body can regulate its temperature. Because all of this energy production, all this faster blood flow through the body, starts to heat the body up. And so at the same time that all these systems are ramping up, your sweat glands activate to try to regulate your body temperature and keep you from overheating. Interestingly, this is almost exactly the same response that we see when we exercise. The increased muscle tension, the increased heart rate, the increased stroke volume, the increased glucose release into the bloodstream, the increased sweating, the increased dilation of the lungs to allow more oxygen in. This is almost exactly the response we see when we exercise. And that actually probably shouldn't be that surprising, because as we've talked about in the past, exercise is itself also a stressor on the body. Now, we'll get into that later, more on that later. For now, let's continue on with the effects on the body. So, the pituitary gland, the P in the HPA axis, also releases a number of additional hormones into the body. First, it releases beta endorphins, which are the body's natural analgesic or pain reliever. And it also releases adrenocorticotropin hormone, or ACTH. We talked about that a little bit last time. And what it does is in turn release cortisol, which we've also talked about a little bit in the past. The cortisol, just to expand a little bit more, leads to additional glucose release into the body, more energy. It also affects the sleep-wake cycle to help keep us alert and awake, because we certainly don't want to be falling asleep in times of stress, but that's actually part of the reason why we have difficulty sleeping when we're stressed. And, as we've talked about in the past, it suppresses the immune system. Now, you might think that suppressing the immune system would be counterproductive or counterintuitive in times of threat and stress. But the immune system is actually there to defend us against infection and disease in the body, rather than from external stressors outside the body. And so, and in fact, we know that if we get a cut or we get an injury and we get swelling, that one of our immediate goals is actually to try to reduce that swelling down in order to reduce the amount of tissue damage at the injury site. And so in a similar vein, under times of stress, cortisol helps to suppress that inflammatory response, suppress that immune system response to help reduce tissue damage throughout the body as a result of the acute stressor. We know this in studies with animals in particular. There are a number of studies, many studies with rats, that demonstrate that rats that are stressed show an increased immune response, sometimes up to 200 or 300% increase in immune system function in times of acute stress. Finally, as we discussed a bit, a number of systems also slow down in times of stress. In particular, the digestive tract, because we don't really need to be digesting in times of stress, slows down. In fact, the smooth muscles in the stomach and in the intestines actually slow down to slow the release of food through our digestive tract, which also slows down the evacuation of food from our system. That's actually, the slowing of the digestive tract is actually what leads to dry mouth, because our salivary glands slow down and stop secreting, and leads to butterflies in the stomach, which is actually the sensation of the slow muscles in the digestive tract slowing down. It leads to uncomfortable feeling for us. In addition, our reproductive system slows down for somewhat obvious reasons, unless you're trying to have sex with a tiger. We won't get into that. But otherwise, it probably doesn't make sense to have a lot of reproductive desire or action in times of acute stress. And so our reproductive system slows down. And in particular, the ability for a man to have an erection takes a bit of a hit, because erection is actually controlled by the parasympathetic nervous system. And so parasympathetic activity rather than sympathetic activity is what helps to allow for an erection. So we see in total a number of systems ramping up, a number of systems ramping up for energy, a number of systems ramping up for freeze and escape, and a number of systems that don't need energy at that point in time, and maybe are counterproductive, slowing down, including immune system response. And in total, that is what's going on in the body during fight-flight.